exercise. Given this Mobius transform, we are going to work out the image of various things using this guy. So the first thing we're going to work out, I believe, is a circle centered on 1 of radius 1. So find f of like this. Okay, so solution. How are we going to do this? So let's draw the complex plane over here, and let's draw the thing we're actually going to set the image of, like this. Okay, and we have a couple of things to, well, we have several things to help us figure out these images. The first thing is that this thing preserves angles. So that helps us tell what is happening when we have things which are crossing. Then the angle has to be preserved. That's the first thing to notice. Okay, and the second thing is the symmetry properties. So we can also put in specific values into our Mobius map to help us figure this stuff out. But before we do that, looking at this circle, what do you think it's going to be? Is it going to be a line or a circle when we map it? We have two possibilities. Is it going to be a line or a circle? What do you think? Let's look at this thing. So what point is being sent to infinity by this Mobius transformation? Negative I, right? No? So unless we hit negative I, we are not actually going to be sent to infinity. So most likely this thing will actually be well, not most likely, for sure it's going to be actually a circle. Yeah? It's going to be a circle. Cool. All right, so what we can do, we can start to put in some points and then start to use some symmetry properties. Okay, so what points shall we put in? So 0 is a convenient point to put in. So f of 0 is equal to -1, right? 2 is a convenient point to put in. Yeah. So let's put in f of 2. So we put 2 into this expression, we're going to have 2 minus I over 2 plus I. That's multiplied by its complex conjugate. So that's the same as 2 minus I squared over 5, right? Multiplying complex conjugate here. And what's that? That's going to be 4. And then I squared is -1. So it's going to be 4 minus 1, which is 3. And then multiplying this, we're going to have this. We have 2 times I carrying twice. It's -4 I over 5, like this. This is this point. Yeah. So let's start to draw some of the stuff. And what do we have? We have that 0 is mapped to -1 over here. And we have that 2 is mapped to this thing, which is, say, somewhere over here. So this is f of 2. And maybe I put this as f of 0. Cool. What about this thing acting on the real line? This is a guy we looked at before. So if we look at this thing acting on the real line, this was the guy that sent the upper half space into a circle. And looking at this on the real line, it sends the real line just to the unit ball, which isn't that useful to us. Don't think it's that useful to us. Okay, let's look at what it does in terms of symmetry. So this thing, if we consider f of 1, right? So on this circle, 1 is symmetrical to infinity, right? Because 1's the center of the circle. Yeah. So 1 and infinity are symmetrical with respect to this circle. So the image of the circle, which is what we're trying to find, will have to be such that f of 1 will have to be symmetric to f of infinity. Yeah. So f of 1 is 1 minus I over 1 plus I, right? And that's the same as 1 minus I squared over 2, which is the same as 1 minus I. So 1, so times I, so minus 1, oops. And then minus 2I over 2, so that's minus I. Yeah? So f of 1 is minus I, which is here. And f of infinity is what? That is just minus 1, like this. So this is minus I, and then this is minus 1. Oops, minus 1. Wait, we have a mistake. F of 0, yeah, this is not minus 1, it's 1. This is just 1, right? So this here is 1. Okay, so it's going to be a circle, and these points are going to be symmetrical with respect to the circle. Yeah? So if it's symmetrical with respect to the circle, that means that the circle is going to have to cross this perpendicularly, so the center of the circle is going to have to be somewhere on this line here. So yeah, look, if we have points which are symmetric with respect to a circle, right, then the direction which goes from this point to its symmetric point has to cut perpendicularly through the circle, and indeed the center of the circle has to be on the same line as these points. Yeah? Yeah. So f of infinity is 1 right here, and the direction that goes from minus 1 to 1 is this direction given by 1 plus I. So we know that this, if we let A be the center of the circle, then we know that A plus IB plus lambda times 1 plus I, this is producing this line, right? And this thing has to go through these points like this, yeah? And wherever the center is, we can use this to reduce this down to just one coordinate. Yeah, because for some lambda, this thing has to equal 1. So this is 1 for some lambda. Along with the real numbers, right? Because this thing here is one of the guys we have to go through with this line. So that's true. So that gives us a way to write this A plus IB equals 1 minus lambda 1 plus IB, which gives us one coordinate instead of 2. Okay, so this is what we're going to use, and we're going to use the fact that we have these guys going through our circle. So these guys are on our circle, So this is on our circle, and this is on our circle, right? And then we're just going to calculate these radii. So 0 is minus 1, okay. It's minus 1. All right, so we have to have that a plus ib minus minus 1, which is plus 1, squared. That's going to be the radius of the circle, is going to be the same as when we do a plus ib minus this guy, which has got coordinates like this, 3 minus 4i over 5, like this, right? So then we can put in our lambda. So then we're going to have this thing here, we're going to have 2 minus lambda. What is this? This is not, there's no b here. Like this, squared, and then this is 1 minus lambda 1. Like this, and then minus this stuff here over 5. Okay, so this has to be true, right? Because they're on the circle, right? And the center of the circle we can represent like this. So this gives us something which is an equation just in 1 lambda, right? Gives an equation just in 1 lambda. Yeah? And then we are able to solve this. We are able to solve this lambda. And I want to make sure I do not make errors, because this was really bad when I made errors previously in working them out. Okay, let's do this. So when we have 2 minus lambda squared, taking the real part of this thing, and then plus lambda squared, which is this thing, right? And then that thing has to be equal to, let's take the real part of this. So then we have, we're going to have 2 over 5 minus lambda squared like this, right? Because that's 5 over 5, and we're taking 1 lambda away. And then for the imaginary part, we are going to have 4 over 5, and then minus lambda, right? Squared, let's check. Yep, that looks good. And let us expand this out. And then what do we get? We're going to get 4 minus 4 lambda plus lambda squared. And expanding this thing out, we are going to get 4 over 25 plus lambda squared minus 4 lambda over 5 plus 16 over 25 minus 8 lambda over 5 plus lambda squared. And then we can, we actually have a 2 lambda squared here, because we get a lambda squared from here. So we have these 2 lambda squareds will cancel like this, this, this. And then what does that give us? That gives us lots of things. So let's put this stuff all together. So let's multiply this. This is a mess expression. Okay, so the 16 plus 4 now becomes 20, so it becomes 20 over 25. So then 20 over 25 is 4 over 5, right? Write that better. have 4/5 from adding these things together. And then from this thing, we're going to have minus 12 lambda over 5. And what we have from this side, we have this thing. So let's write this as 20/5. So let's put this thing over here. So let's write this as 20. Is it over 5? So 5. This is it correct? Yes. 20/5 minus 4 lambda. Let's put this over 5. So 20 lambda over 5. So this is equal to this. Let's put that on the other side. So put this on let's add this thing to that side. So then that implies that we have 8 lambda over 5. And then putting the other stuff on the other side is equal to 16/5, which implies that lambda is equal to 2. Good. Cool. So, since we know the center is on a line like this, which has to go down from, or up, whatever you want, from 1, we've now found that this lambda has equal to 2, so our center, therefore, has to be given by this thing right here, right? So, from star, this implies that our center, A plus IB, has to equal this thing. So it's 1 minus 2, which is minus 1, and minus 2i. Okay, and this being the case, we can now find the radius because we can put into either of these things. So this is the radius squared. So if we put into this thing, then we have that, we're just going to have that minus 2i, because we're just adding 1, squared is the radius squared, which implies that the radius is equal to 2. Okay, so it seems that we are with a circle of radius 2 centered on 1 minus 1 minus 2. Okay, so minus 1 minus 2 is something like this. Minus 1 minus 2 is like this. So if it's got radius 2, then it should go through. Should go through like this. Right, okay. So it goes through like this. And this point is this point over here, which, you know, it's just approximation, actually must live somewhere here. What was this? This was f of 2. Okay, so this is what our circle must be, and sure enough, it lives on this line, and this point are symmetrical with respect to the circle.